We'll use the vertex and the intercepts to graph our next quadratic function. We'll also find the axis of symmetry and then state the domain and the range of this function. We have f of x equals x squared minus 2x minus 3. This quadratic function is given in standard form of f of x is equal to ax squared plus bx plus c. Whenever we have our quadratic function given in this standard form, we can use the formula for the vertex. But before we do that, let's first of all state whether it opens up or opens down. Since our a in this case is 1, a is greater than 0, so our parabola or our quadratic function opens up. In step 2, we want to find the vertex. In order to find the vertex, it's going to have an x and a y coordinate. The x coordinate of the vertex is given by the formula negative b over 2a. So in our case, it's negative b, which is negative 2, over 2 times a, which is 1. This reduces to positive 1. So the x-coordinate of the vertex is positive 1. In order to find the y-coordinate of the vertex, we just substitute 1 in for x in our quadratic function. In other words, we're finding f of 1, which is equal to 1 squared minus 2 times 1 minus 3. That gives us 1 minus 2 minus 3, which gives us negative 4. So our vertex is 1, negative 4. In step 3, we want to find the axis of symmetry. The axis of symmetry is just a vertical line for a quadratic function, and the formula is x is equal to whatever the x-coordinate of the vertex is. X equals 1 in this case. The last thing we need to do to help us graph this quadratic function is to find the x-intercepts and the y-intercept. So in step 4, we'll find the x-intercepts by letting y equal 0. When we do that, we're solving the quadratic equation 0 equals x squared minus 2x minus 3. This will factor, and we get 0 equals x minus 3 times the quantity x plus 1. And if we set each of these factors equal to 0, if we set x minus 3 equal to 0, we get the x-intercept of 3. And if we set x plus 1 equal to 0, we get the x-intercept of negative 1. Let's also find the y-intercept. The y-intercept we can find by letting x equal 0. If we let x equal 0, that's really finding f of 0. That will be 0 squared minus 2 times 0 minus 3, or simply negative 3. Now we're ready to sketch this quadratic function. We know, first of all, that it opens up, and we know the axis of symmetry is the line x is equal to 1. So let's draw in our axis of symmetry, the vertical line, going through 1 on the x-axis. Next, we'll plot the vertex, 1, negative 4, on the axis of symmetry. We'll also plot the two x-intercepts we found, 3 and negative 1. So positive 3 and negative 1. And finally, the y-intercept is negative 3. Now we'll sketch this and make a smooth curve. This is the graph of our function f of x. Now by looking at the graph, we can see the domain and the range. So the domain for any quadratic function is all real numbers. In other words, we can let x equal any real number. The range in this case. If we look at our graph, we can see that the smallest y value we see on our graph here at the vertex is -4. So the y values go as low as -4 or greater than -4. So the range is on the closed interval from -4 to +infinity.